Okay, so we have two more concepts. There are two more concepts that I want to cover, and today we'll start with the area between two curves. So that word here says curves. I know it's kind of not written very well. Anyway, let's start with an example. So example one, and yeah, basically find the area between two curves. Area between two curves. Yeah, as you can see, I'm having problem with that curves, that word. I don't know why. It's not a difficult word. This is V. And okay, here we go. Yeah, so those two curves are, well, let me maybe write it. How should I write it? Let's write it like this. So f of x, or actually no. Sorry, I changed my mind. Let's do it this way. So y1 equals f of x, and then we have x squared. So that's the first curve. The second curve, let's call it f of x as well. Yeah, so I'm distinguishing between those two by naming the first one f1, y1, and the other one y2. So the second one is x cubed. And yeah, let's start with the graph. Right, so we have one of them is a parabola, right, and the other one is just a cubic function. So parabola gets, like, if this is 1, actually, let's make that 1 a little bit farther. Okay, so this is my x-axis. Let's make that 1 here. And when you look at that, those two curves, and especially the positive side of it, the parabola starts pretty steep, right? It's steeper than the other function and the cubic function. But then the cubic function gets steeper, right? So it's kind of like this. So this one is initially, yeah, I'm trying to draw it nicely for you, but as usual, I struggle. Anyway, so it's something like this. Right? And then it gets steeper. Yeah, I didn't draw that part, right? But you get the picture, right? So the blue one is the cubic function, so y2 equals x cubed. And the white graph is a parabola. So y1 equals x squared. Right? And the area we're finding is this area between those two curves. Okay, so of course, yeah, we're using two integrals, and the area that we're supposed to find is between 0 and 1. Okay. Yeah, so the area will be, the way we'll approach this problem is basically we'll take, we know how to calculate, so let's say I'm looking at this, I'm looking at the white function, right, that is the parabola, and the way I'll approach the problem, we'll calculate the area of below the white curve, right? So I'm thinking how to draw it so that you can see it. Maybe I'll try to make another picture, a better one. Maybe the graphs will not be as accurate, but I'll make that area between those two curves slightly bigger. Okay, so the idea is like this, right? So we have that point here, and say, let me make that point a little farther. Okay, so here. Right, so the idea is this, right? So this is the, let's say this is, well, let's keep the same colors, right? So this was parabola, and the other one was blue. The other function was the cubic. Okay, I don't know if this is better, but hopefully yes. This is 1. 0 here, obviously. Yeah, so the idea is like this. Let me get maybe the laser thing. Okay, so we have, right, we know how to calculate area between, below a curve, right, or between the curve, right, we know how to calculate that, and the x-axis, right, so that would be a definite integral from 0 to 1, right, of that particular curve or function. Let me label them. So y equals x squared, and the blue one is y equals x cubed. Okay, so yeah, to calculate the area between them, right, it's kind of conceptually pretty easy, right? So we would calculate the area below the white curve and then subtract the area below the blue curve, right? So that's going to give us that. The difference will be this, right? So we're subtracting the bigger area minus the smaller area, right? So one more time, between or below the white curve minus the area below the blue curve. Okay, like this. Okay, so let me go back to this, and I'll put those that equation here. Okay, so we have from 0 to 1, and these are our boundaries of integration, and then we're subtracting we're subtracting the area below y2 from the area below y1. So like this, y1 minus y2, and basically that is it. Okay, so we have this bigger area minus smaller area, right, will give us the difference, right, the area between those curves. Okay, yeah, so let's put those expression for those functions in. So I will have equal sign, and then we have from 0 to 1, and then y1 minus y2. So x squared minus x cubed dx. Okay, so yeah, we just do those two integrals separately, right? In other words, I can just put that, do this, right, integral in there, and let's actually do it without putting that integral there. So I'll have integral of x squared is right, so I add 1, remind you, so plus 1, and then that 3 goes to the into the denominator, right? So we have 1/3 x cubed. Okay, then I go minus 1/4 x to the 4th. Okay, and then we have those two boundaries of integration from 0 to 1. All right, and we're plugging in first the first one, the top one, right, into both places, and then the second one. Right, the second one is just going to be 0. Anyway, so I go 1/3 1 to the 3rd power, right? Then I have minus 1/4, again 1 to the 4th power, and then we go minus, right? And then the second time through, right, we could, I'm not going to write it, it's just 0, right? And then I'm plugging the 0 into both places, right? So minus 0. If we were doing it, if I was doing it, if that was a number, if this was a number other than 0, right? It would be, I don't know, 3 or 0.5 maybe, it would make more sense. And I would need to put that in parentheses, right? So I'll be plugging in that, so it'll be 1/3, minus 1/4, with that number in, right? So then you would take this negative and distribute that negative to both numbers. Right? Don't forget that when we're solving definite integral, the solution, the answer is a number. Anyway, well, let's write that 0, so minus 0. Okay, so we do the arithmetic, and we get 1/12. Okay, so yeah, that's basically the idea, right? The concept. This was quite easy. It can get slightly more complicated, especially if we have to actually calculate what that point is, those 2 points of intersection, right, of those two curves, and then the area between those two curves. So let me show you an example of something like that. Okay, so let's look at another example. Example 2. And it goes like this. So find the area between two curves again. And the curves are y equals 2 minus x squared. That's the first curve. And y equals x. Okay, yeah, so first thing we need to do is find the intersection points. And yeah, the idea is that, right, when you find those intersection points, the y value and the x value of those 2 points for both curves will be the same. Right, so we have right, those 2 curves. Right, this is just a straight line. Right? It's not really a curve, but we're going to call it a curve anyway. Yeah, so the fact, right, when 2 curves, I'm just going to sketch. I'm not going to graph this particular graph, but those 2 particular functions. But there's something like this, right? So if there's a point here and then point there, the coordinates for both of those points are going to be the same for both curves, right? So -2, I don't know, that could be 3, right? So that's this point, right? And then x and y are the same for both of the curves, right? It's the same, that point lies on this curve and also on this. So we'll use that fact, right, to calculate those 2 points of intersection. And what we'll do, we'll just make the y, right? So if we call this one y1, this one y2, we'll calculate those 2 points by making y1 equal y2. Okay, so here we go. So 2 minus x squared equals x, right? And we need to solve it for x. Right, so yeah, just kind of, the way I usually do it is just I would probably move this thing there and that thing there, right? And then kind of switch the signs. I hope you know what I'm talking about. And it doesn't matter where I put that equal sign, right? I can put it on either side. But normally we would put it on the right side. -2 equals 0. Alright, so one more time, I don't know. I have no idea how strong your algebraic skills are. But moving this one over here, right? So that's going to be positive x squared. Moving this one over there, -2. And this equal sign equals 0 can be here or can be here, right? Doesn't matter. Anyway, yeah, so we have a quadratic equation. We factor it. We're looking for 2 x's. When we multiply them, right, so factoring, I would get negative 2 when we add them. Would get me positive 1. And those two x's, those two numbers, would finally end up here. Right? So those two numbers are, what are they? I guess I need to have positive x, right? Positive 1. So plus 2 minus 1. I don't know, you probably have seen, right? It's like a little device that helps you organize, right? Those numbers, this factoring. So negative 2, 1, right? And you're looking for these two numbers, right? So 2 and negative 1, right? When we multiply these two, get this. When we add these two, we get 1. Anyway, so now we need to solve it for x. So you're looking for two x's that would make this whole expression equal to 0. So first one would be negative 2. The second one would be 1. Okay, so we have the x's. So now we need to find the y's. To find the y, we have two expressions for y, right? First one, second one. Looks like that second one is easier, so I can just plug in my x's. Right? So this is what I'm doing. Plug. Oh, I can't really. That's I can't cross those pages. Anyway, I'm plugging this negative 2 here, and then 1 also here. Okay, so I'm getting y equals negative 2 and y equals 1. Okay, so those points are intersection points. And they are negative 2, and 1, 1. Okay, yeah, so we found the points. I have a graph here, so I'm just going to show it to you. I'm not going to try to be particularly exact, but the first is a parabola, right? So it's 2 minus x squared, so parabola that crosses the y-axis at 2. And I don't know where it crosses the x-axis, but it doesn't matter. Okay, so that's that parabola. This is 2. And then, of course, it's far from perfect, but I should have made this graph those points first. Anyway, yeah, so we have 2 points of intersection, right? So first one, that's positive 1. And the second one, well, it is what it is. And here's my line. Again, right? It's not perfect. At least it's going through the origin, right? That's pretty good. Okay, so this is y equals x, and this is that parabola. So 2 minus x squared. Okay, so now, right, we're ready to write that integral for area. And you see, and it's kind of like, I'm not sure. I don't think I mentioned that, but it's good to keep track which, and when we're calculating those areas, it's good to keep track which curve is on top. And so I'll be subtracting this from that. All right. So let's look. Let me just label those. So y1 was the red one. So this is y1. And the other one, the blue one, was y2. Okay. So let's write that equation, that integral for area. So that area is, so we have integral from, and when we look at that interval, the interval will be the x's, right? Well, in our case, those two x's and y's are the same. So this point is negative 2, So it doesn't really matter, but in most cases, right, the x's and y's are not the same. And this one is 1, 1. Right, so when I'm writing this integral, right, the boundaries, this is supposed to be 0. Right, I'm writing those two numbers here, right, those two endpoints of that interval. Right, I'm taking them from the x values here. Okay, so that's going to be from -2 to 1. Okay, so I go y1 minus y2, and then dx. Okay, so let's finish it. Let's put those two expressions in. So from -2 to 1, and then we do the first one, right? Is -x squared plus 2, or 2 minus x squared. -x squared plus 2, and then minus x dx. Okay, so we take an integral of both of those functions. So when I do the first one, it's going to be -1/3. I hope you're getting comfortable with that, with integrating. And then 2 will give me, the integral of 2 is 2x, so plus 2x. Integral of x, or -x, is -12, right? X squared. Okay, so we're evaluating this whole expression for -2 and 1. Okay, so yeah, pretty difficult arithmetic. Difficult because it's just kind of difficult to keep track of what's going on. Anyway, looks like the answer I got is 9/2. Okay, so that's the area between those two curves. And yeah, let me do one more example of this particular section. So example 3. Okay, and find the area. Okay, so the equations we have, the first one is 3x cubed minus x squared minus 10x. And then the second one, g of x. This is x, -x squared plus 2x. Okay, so again, right, we need to find, or maybe, just treat it as a practice problem that I will in a moment go over. So pause the video and try to figure it out. Try to figure out the area between these two curves. Yeah, I didn't really do much of arithmetic here. Anyway, so I hope you solved that problem, and yeah, let me show you what I have. So the first step, I'm trying to find the points of intersection. So I'm taking this first function, and it's the same concept, right? Just making the y's equal, minus x squared minus 10x, and that equals to -x squared plus 2x. Okay, so yeah, we move things around, simplify, cancel, combine like terms, and we get 3x cubed minus 12x equals 0. Okay, so that's the final equation I have. This is cubed over here. Okay. Yeah, so we try to factor it. So what I have is this. X minus 2. And then x plus 2 equals 0. Alright, so those x's will be 0. Alright, I got it. I got that 0 from this particular factor. And if you plug in 0 here, right, you get 0. Anyway, so 0, 2, negative 2. And then, right, I calculate the y values. So finally the points are, what I have is negative 2, negative 8. Negative 2, negative 8. Then I have 0, 0, so origin. And then I have 2, 0. Okay, so these are the points of intersection. And yeah, so let me actually show you the graph now. Okay, so the first function is a cubic function. Let me make it more this way. Okay, so yeah, origin. So maybe the first, let's make it blue. Right, so that's the first one is 3x cubed minus x squared minus 10x. It goes through also negative 2, negative 8. Right? So that's that. Of course, now I don't have enough space. So let's make that point maybe here. Okay, then I have the origin. And then the last point is 2, 0. So let's make it here. Okay, so now the cubic will look like this. Right, so of course, right, so goes up. Nah. Like somehow I thought that 0, 0 is the only, or that there are only 2 x-intercepts, but there are actually 3. Anyway, so we go up here, and then down, down, and up. Okay, so that's this cubic. So y equals 3x cubed minus x squared minus 10x. Okay, so that's that cubic function, and then we have a parabola. Parabola, just kind of look at it. Let's make it red. Right, so it's supposed to, right? It's supposed to go through the same 3 points. Right, so I'll try to draw it as best as I can. Okay, so that's the parabola, and now it goes down here, right? Through this point, negative 2, negative 8. Right, so let's label those points. Let's label it with a different color. Make them yellow. So this one is negative 2, negative 8, right? That's that point. We have 0, 0. And that's obviously the origin. And then we have 2, 0. That's this point. 2, 0. This is not 6. Okay, so now the area between those two curves, I hope you see it, right? So it's this one here. This. And then obviously it's this. Okay, so let's write that integral. Right, so you understand that this is not what I guess the difficulty here is more conceptual and kind of understanding that well, understanding the process, right? That you need to find those points of intersection and then subtract those two curves. But in general, right, this is pretty easy. What, what I'm trying to say is that once you know what to do, it's very easy to execute it, right? To actually do the problem. Okay, so right, so we're looking again, right, at those x's. So we're calculating we're calculating two areas, right? We're doing this one. Right? We're calculating this area between these two curves. Right, so that's going to be from -2 to 0, and then the second integral is going to be from 0 to 2. Okay, so let's do it. So I have -2 to 0, so that's that first area. I should have made those area different colors, but too late now. Okay, so that's going to be f of x. That's this cubic. Let me actually color code it. Do I have another color for the... Yeah, so let's make that... I'm going to try to make this, you see, I'm trying to make that that second area yellow, but I'm not sure if it'll work out. Alright, so those two areas. Right? The first one is green and the other one is yellow. So I'm doing the green one first, and it's gonna be f of x minus, and the parabola was g of x. Okay, so that's that the green area, dx. Okay, and we're going to add the other one. So plus another integral. This one is from 0 to 2. Right? From 0 to 2. And this time, right, I'm doing it the other way, right? So I'm subtracting because the red parabola is on top, right? So g of x minus f of x. Okay, and dx. And that is the yellow area. Okay. Okay, yeah, so if you want, you can do the arithmetic. What I got is 12 for both of those areas. So when you add them up, it's going to be 24. So 24 square units. Okay. Yeah, so I have a problem for practice for you to do. Just if you want, obviously you can do the whole problem. But I don't expect you to do that arithmetic. Anyway, yeah, so calculate the area between those two curves. But what I would like you to do is to draw it and to calculate those points of intersection and then write that integral. And then, yeah, arithmetic, you don't need to actually calculate it. I mean, you can, I don't know, use Google or something. Okay, so this is these are the two curves, and the solution is 64/3 units. Okay. Okay, so I have one more example, two more examples. So so you can use the properties of even or odd functions to simplify that arithmetic. So let me show you. So area, let's make it yellow. Let's make it just regular regular white. So area with even and odd functions. Okay, so let's calculate the area of under a curve of an absolute value function between -5 and 5. Right, so normally you would let me graph it first actually. Okay, so here is that absolute value function. Let's say this is -5, this is 5. Okay, and we're calculating this area. And the way I drew it is not particularly clear, but you see that the function is symmetrical, right? So that's what it means to be even, right? The function is so symmetrical with respect to the y-axis. So that's what it means to be even, right? So the function is even, right? So if you're doing this just regular way, you would take and calculate that area on an interval from -5 to 5, right? So these would be the endpoints, and then we would have that absolute value of x dx. Okay, but the way we actually can do it is we can simply just take, right? So these two areas are the same, so we can calculate one of them. Let's say maybe this one, right? Because it's that 5 is positive, and then double it. Right? So I'll put 2, and then we'll have those endpoints from 0 to 5, and then we calculate integral of absolute value of x dx. Okay, so we get 2. Integral of that absolute value of x is going to be x squared over 2, and then those boundaries are 0 to 5. Right, so I think it's just easier to have that 0 here, right, rather than -5, and then arithmetic it's just easier. Okay, yeah, so this was an even function. Let me quickly show you a function that's odd. Okay, so let's say we have, what do I have? Okay, so y equals x cubed. I'm just looking at it. So the function is y equals x cubed. Yeah, I wasn't sure about that. There are two functions. The way I have it in my notes, it's just not clear. And let's say we're supposed to do between -3 and 3, right? So these are the points. Here's the graph. Okay, so here are the areas. And again, right, those areas are symmetrical. So this area is the same as this area. This is -3. This is 3. Okay, so when we calculate this, okay, so similarly, right, this integral would look like, so I could go from 0 to 3, and then just have that x cube here, dx, and then double that area. And so I put that 2 in the front. Okay, yeah, so that's it for that particular section. And yeah, there is one more section that I want to do.